domains, ranges, and intercepts of functions. So our objective here, identify the domain, the range, and the intercepts of a function from its graph. Okay, we know a few things coming into this that are going to help us. So we know what a function is, a relation in which each component of the domain, each input value or each x value, corresponds to exactly one component of the range, each an output value or a y value. We know what intercepts are. Intercepts are where a graph crosses or touches an axis. So the x-intercept is where a graph crosses or touches the x-axis. By the way, x-intercepts are also called the function's zeros. A y-intercept is where the graph crosses or touches the y-axis. Okay, notation for domains and ranges looks as follows. We have interval notation, which specifies all the numbers between two given numbers. And as hard to see here, bracket. A bracket means include. Okay, an open parenthesis, okay, means don't include. So this, in interval notation, this says all the numbers between 0 and 20, including 0, because there's a square bracket next to the 0, and including 20, because there's a square bracket next to the 20. Okay, this in set we also have set builder notation, which is a description of numbers by property or properties. And these are curly brackets, a little hard to see, didn't print out quite so darkly. Okay, well, the brackets tell us it's a set, so the set of all x, the vertical line replaces such that, and then here's the property. X is greater than 0. So this tells us any number as long as it is larger than 0. 0.00001, 1/5, 2, a million. Okay, any number as long as it's larger than 0. So let's take a look at this with our functions, and let's kind of work our way through defining the domains, the ranges, and the intercepts using our notation. Okay, identify the domain, the range, and the intercepts for each function's graph. Remember, our domain is our x values, and our range is our y values. Okay, so the domain, x values. Well, the x values are the horizontal values, and they go from here to here. That's our domain. Okay, our domain, the x values for this function, and we go from left to right along the x-axis, go from -2 to +1. Okay, so the domain in interval notation, because we have a closed circle, we include the -2 and we go from least to greatest. And because we have a closed circle here, we include the +1. Okay, so the domain, the x values go from -2, to +1, include the endpoints and everything in between. And this is interval notation. Okay, in set builder notation, the domain is the set of all x's such that, well, x is greater than or equal to -2, and x is less than or equal to +1. So x is between and including -2 and +1. It looks like this in set builder. Okay, SB, I'll call it SB notation. SB, of course, standing for set builder. Okay, so what's the range? Okay, well, the range is the y values. Well, the y values, again, going from smallest numbers to the largest numbers means going from bottom to top, and we're going from here to here. Okay, so this is the range in this particular graph. The range of these, in this graph, the values go from 0 on the y-axis up to positive 3 on the y-axis. Excuse me, inclusive, because I have closed circles. So from 0 to positive 3 is the range of this graph. Okay, in set builder notation, the set of all y's such that, well, y is between 0 and positive 3, inclusive. And this is your set builder notation. Okay, so we've identified the domain in interval notation and set builder notation, and we've identified the range in interval notation and set builder notation. Now the intercepts, x-intercept. Okay, where does the graph cross or touch the x-axis? Well, in only one place, at -2. And recall, the x-intercept is also called a 0 of the function. And there is an x-intercept or a 0 at -2. That's where it crosses or touches the x-axis. Is there a y-intercept? Yes, there is. Where does it cross or touch the y-axis? Right here at +1. So there's a y-intercept at 1. So there you have it. Working with using the graph to define the domain and the range in two different notations, as well as determining the x-intercept or 0 and the y-intercept. Let's do a few more examples. I think I've got 3 lined up for you. This takes a little bit of practice sometimes. So I want to do a few examples. Get my sheet lined up, I hope. Okay, give me a second to get my notes together. Okay, and this one, okay, the domain, the x values go from here to here. That's the domain. And notice we have an open circle here. It's an open circle, so we're not going to include -3, but we have a closed circle on this end, so we do want to include 2. Okay, so the domain in interval notation does not include -3, but does include 2. So an open parenthesis for the -3 and a closed bracket, okay, for the 2. Okay, that's the domain from -3 to 2, not including -3. In set builder notation, the set of all x's such that, well, x is between -3 and 2, but it doesn't include -3. So start at -3, x is greater than but not equal to x, but it's less than or equal to +2. Okay, what's the range? Need some more lead, it looks like. Okay, the range, well, the range is only going from here to here on the y-axis. This is the range right here. It's a very small range. It only goes from 1 to 2 in the y direction. And again, 1 not even included. Okay, so the range in set notation, in interval notation, the range goes from 1, but don't include it because it's an open circle, up to 2. But you do include it because that's a closed circle. In set builder notation, the set of all y's such that y is greater than 1, but y is less than or equal to 2. Close the brackets, okay? So do we have any x-intercepts? Is there any place the graph touches or crosses the x-axis? And the answer is no. So there are no x-intercepts or no zeros. We do have a y-intercept. We have 1. There is one place, a y-intercept. There is one place it crosses, and I'm just going to ballpark this. It looks like it's approximately, let's say 1.6. And I'll just use the curly equals at approximately 1.6. I don't know exactly what it is, but that's close enough for what we're doing right now. Okay, letter C. Let's do a third one here. This is the graph of a function. Again, if we use the vertical line test, any vertical line only crosses that graph in one place. What's the domain? Well, the domain goes, in the x direction, goes from here to here. So this is the domain, from -2 to +1. Notice at -2 we've got a closed circle, and notice at +1 we have an open circle. Okay, so in interval notation, we go from -2, but it's included, so a bracket. And we stop at +1, so we don't include it, not included, so an open parenthesis. In set builder notation, the set of all x's such that, that's that vertical line, where between -2 and 1, we include -2, so x is greater than or equal to -2, but we do not include the 1 because of the open circle here in the graph. Okay, let's take a look at the range. Range is a little bit funky. The range goes from here's the low point, and here's the high point. So don't let this little bottom curl part throw you. The range is the set of all y values the function can take on, and that goes from +1, including +1, all the way to +5. Okay, it includes it because there's no circle, open circle down here. So the range goes from +1 to +5, and they're both included. Okay, how about in set builder notation? The set of all y's such that y is between 1 and 5, and both of those are included. Okay, x-intercepts, or zeros. Okay, well, this graph does not touch or cross the x-axis, so none. Y-intercept. There's a y-intercept here at +1 where it crosses or touches the y-axis. There's a y-intercept at 1. Okay, last example, we'll throw in a use of the infinity symbol. Okay, so here's my graph of a function. We know that. We can draw any vertical line we like. It'll only touch it in one place, so it's the graph of a function. It also notes that here that y is a function. Okay, let's look at our x values. Well, they go from here, and they go forever in that direction. And this function says, we have an arrow here, note the arrow. So this function goes on forever in the negative direction. So this is our domain, okay? So our domain, and again, we always list our domain in both, let me get up here so you can see, in both interval notation and set builder notation, we always list it from least to greatest. Well, okay, here we are. Well, the least is -infinity. Okay, this graph goes in the x direction. This graph goes all the way, just keeps going to -infinity. Oops, sorry about that. So our domain, infinity and -infinity always have an open parenthesis because they're not specific numbers, okay? So our domain goes from -infinity and it stops at 4, and notice that 4 is a closed circle. So we have a bracket next to the 4. The domain is from -infinity all the way up, -3, -2, -1, 0, and up to 4. Hard stop at 4, including 4. This is interval notation. Set builder notation, the set of all x's such that x is less than or equal to 4. Of course, you could also write that x is between -infinity and 4, but this is the shorter, cleaner way to do it. It's all x's that are less than or equal to 4. Okay, let's take a look at the range. Okay, the range this is the lowest part of the range here, but this graph goes, it doesn't climb, it's not climbing very fast, but it is still climbing. It will climb all the way to positive infinity. So the range is this. Okay, again, it's climbing slower and slower and slower, but it will continue to climb all the way, it just continue to climb to positive infinity. So again, we go from least to greatest in the y direction, from 0 to positive infinity. 0 is included because we have a closed circle. So the range goes from 0 all the way to positive infinity. And again, because infinity is not a specific number, it is always enclosed with a parenthesis. Never use a bracket with infinity. In set builder notation, the set of all y's such that y is greater than or equal to 0. And that's the short way to do it. Y greater than or equal to 0. Of course, you could also say that y is between 0 and positive infinity, equal to 0, never equal to positive infinity. Okay, a y greater than or equal to 0. Okay, do we have an x-intercept or a 0? Is there any place that the graph touches the x-axis? And the answer is yes, it touches it at 4. So we have an x-intercept or a 0 at 4. We'll get more into zeros coming up later. And do we have a y-intercept? And we do. The graph crosses or touches at positive 2, a y-intercept at 2. Okay, so there you have it. A fair amount of practice on interval notation, set builder notation, what domains and ranges are and how to write them, and then recognizing from a graph what's the x-intercept or the 0 if it has one, and the y-intercept if it has one.